Hi, my name is Srini and this is the final project presentation for the project called Integrating Insights from Non-Structured Community Data into EHRs. We are a team of 6 members comprising of 4 developers and 2 project managers/QA. Before I speak about our work, let me give you all a little background on why we chose to do this. Why is such a project even necessary in the first place? We all understand that a clinician is a healthcare professional that works as a primary caregiver for a patient in a hospital, skilled nursing facility, or a clinic. Clinicians run into issues when they want to review their patient data from an external source like community health centers, because these data sources don't necessarily follow any standard data definition. This makes it hard as a lot of unnecessary information gets accompanied with useful patient information that clinicians are primarily concerned about. Since time is an asset for clinicians, we built this application that only extracts patient information that is relevant and valuable for a clinician. Using this data, a clinician is able to understand their patient's health history and progress quickly so they can provide their recommendations. Our application provides a unified view of all relevant patient data that is valuable to a clinician. Since the data was not readily available for us to use, we chose the route to generate synthetic data by ourselves for the scope of this project. Here is an example of synthetic data that we have generated. You can see there is a lot of information that is not relevant and will not help a clinician perform his job efficiently. For example, organization code, participation ID, ethnicity, education, and so on. Here's an overview of our high-level architecture. Orange represents the project-specific components we have built, and blue represents the open source components we have consumed for this project in the semester. In this diagram, patient data represents the synthetic data we discussed earlier in our example. This patient data is sent to an extractor component, and then this data is ingested into our database in a FHIR-compatible format. This extractor component is responsible for extracting the patient data that is helpful for a clinician to understand his patient's history and how he has progressed over a period. We have also built an insights component, which is the brain of our front-end service. I will demonstrate our front-end in just a little bit. Let us take a moment to understand how we operate with EHR, our second data source. As you can see, for the scope of this project, we have used Cerner as our EHR source, and Smart on FHIR helps us in authorizing our front end to access the data available in Cerner EHR. In addition to accessing the Cerner EHR using Smart on FHIR, the backend server, which is our insights component, also has a connection to other public FHIR servers to extract other information as and when necessary. Our application can work with both data sources and still be able to present this data to a clinician in a FHIR-compatible format. When I say both data sources, I mean EHR, which has a standard data definition, and synthetic data, which has no standard data definition. Let me talk a little bit about our technical stack. We have used Node.js as our primary programming language. MongoDB is our choice for database in this project. GitHub has been integrated with Jenkins for self-deployment. Our application and MongoDB has been deployed as a Docker container. As you all know, I promised earlier to go over our front end, so here we are. Let's go ahead and create a testing environment for an IHI provider which can access record for multiple patients. Let's choose a patient called Timmy Smart. Now here is a unified view of this patient's data that is valuable to a clinician. Our application has 4 primary sections, and I will discuss each one of them with you. Community programs, data served. This section shows the program type and the patient has enrolled in along with their dates. It also provides the organization for each program type. On the right of the screen, we can observe that the number of sessions the patient has attended has grown over a period. The next section gives the actual measurement of the patient for each program type. The blue section indicates data from FHIR and the black text indicates synthetic data. As you can see, the body weight of the patient in August 2016 was around 90 pounds and the hemoglobin A1C was at 11%. We present these values for different periods and the last recorded data for body weight is 100 pounds and A1C is at 7% for this patient. Let's look at trend. So trend analysis, why is this important? Trend analysis gives a holistic view of the patient's progress over a time period. It captures a clinician's attention and makes it easier for him to assess how his patient is responding to medication. In this example, we are discussing 2 program types and we will show you the trend for both body weight and hemoglobin A1C. Let's look at the body weight trend. As you can see, this section gives a trend of the patient's body weight from October 2007 all the way till July 2018. Moving on, the trend for hemoglobin A1C gives you the trend from the date August 2016 all the way till July 2018. Let's look at the analysis section. This section gives the analysis of the program type for this patient. In this case, we can observe that the patient has gained 10 pounds since starting the program and has lost A1C level by 1%. For Health 7 International, the patient has gained 10 pounds and has lost 4% in A1C. Overall, the patient seems to be improving his health starting this program. With this demo, we prove that our application can integrate insights from non-structured data into EHRs. This project is built as a framework, allowing anyone to extend the observations, adding corresponding ETLs as a plugin, rendering more cards in the dashboard. Team Ninjas would like to thank our professors and mentors who helped us at every stage in this project. Thank you.